Okay, so this one here, differentiate dy by dx. Sine goes to cos, so it's going to be cos of x. But remember, we've got to use the composite rule, so we've got to times that by the derivative of that bracket. I don't need to simplify, so I'm not going to there. Dy by dx here is, well, that's a parametric equation, isn't it? So dy by dx is dy over dt times by dt over dx. So from here, dx by dt to, again, sine goes to cos, so it's 2 cos t. From there, I find it easier to talk about 3t to negative 2. So dy by dx, dy by dt, make sure you got that looks right, dy by dt, that is going to be negative 6 t to the negative 3. So dy by dt, negative 6t to the negative 3, times that by dt over dx. Remember, that's just the inverse of that. It's 1 over 2 cos, wow, 2 cos t, making it look a bit pretty. I do not need to simplify that. You obviously can, you're not getting penalised if you do, just saying you don't have to. So in the last one, find the gradient of the function when x equals 2. Right, so first of all, we're going to differentiate dy by dx, got to differentiate that. Now log goes to 1 over log, but remember I have to differentiate that bracket, which is going to be 2x minus 3, and then don't forget this plus 2 there, plus 2x. So if I write that a little bit nicer, that's going to be 2x minus 3 all over x squared minus 3x plus 2x. Now when x equals 2, dy by dx is going to be 2x, 4 minus 3, x squared, 4 minus 2 lots of 3, which is 6, plus 2 lots of 2, which is 4. 4 minus 3 is 1, 4 minus 2 is negative 2, so it's going to be negative a half, plus 4, which gives me an answer of 3 and 1/2. Just looking at the marking schedule, I think that's pretty self-explanatory for achieved here. So either one of these got you an achieved, but either that got you a merit. Remember, this is the or equivalent part. Correct derivative, so up here got you your achieved tick, and in your 3.5 got you your merit tick. So this question here, we're trying to find the rate at which the height is changing. So we're trying to find dh by dt. Now to do that, we're going to find dh by something times by something over dt. Now the dt we're given is it's poured at a rate of that. That's a volume, so that's dv. So dh by dv. Now what we're going to be able to do is, okay, with this base area, so the area of the circle is pi r squared, or 2500 pi r squared, so the radius is 50. With a height of 300, what we can assume is there is a relationship between the radius and the height, and the radius is just 1/6 of the height. Now what this will allow us to do, it will allow us to use the volume of a cone formula, which is 1/3 pi r squared h, and substitute in there. So we've got a function for volume with respect to height. So it's 1/3 pi 1 over 6 h squared times h. 1/6 squared is 1 over 36 times 3 gives you 108. So it's 108 pi h cubed. Now that is v, so now we can get dv by dh, times that by 3, that's going to be 1/36 pi h squared. Now, I mean, remember we want over here, we want dh by dv, so dh by dv is just the reciprocal of that, so everything is upside down, so it's going to be 36 over pi h squared. So into this formula over here, 36 over pi h squared times it by the rate at which it's changing, which is 350, gives us an answer of, I'll just do my calculations. So that calculation, 36 times 350 is 12600 over pi h squared. Now, when the water is 100 ml from the top, so that's h is 200, we get an answer of dh by dt is 12,600 divided by pi times 200 squared. So that divided by pi lots of 200 squared, which should give you an answer of 0.1. Now these are all in millimeters. So the height is in millimeters, that's millimeters, that was in seconds, so millimeters per second. Alright, again, so looking at this, any correct derivative, you needed to form the equations through here, okay, and probably needed to help form this, would have helped you with your correct derivative. Giving you that was your merit, final answer, excellence. Okay, so E here, we're trying to prove that no stationary points. Remember, stationary points when dy by dx equals 0. Okay, point of inflection, well that's when d squared y by dx squared, the second derivative, is 0. So no stationary points, this cannot be 0. Point of inflection, this will be 0. Okay, so let's go through it. So dy by dx is going to be, that's the quotient rule, so write down the bottom times the differential of the top, minus, write down the top, differential of the bottom, all over, sorry, differential of the bottom is simply just 2x, isn't it? This is all over x squared minus 1 all squared. Okay, so let's just expand the top one just to make it a little bit prettier. Now that there, I can actually simplify the top to be negative 2x squared minus 2 all over x squared minus 1. And if I want to, that's going to be negative 2 into x squared plus 1 all over x squared minus 1 all squared. Okay, now stationary points, remember, this can equal 0, so stationary point can negative 2 x squared plus 1 all over x squared minus 1 squared equals 0. Now for it to equal 0, it's really just got to be that top line. It's got to be negative 2 into x squared plus 1 equals 0, which in actual fact is just x squared plus 1 equals 0. But in reality, without imaginary numbers, we can't solve that. So there is no stationary points. Okay. Now we need to prove this point of inflection part. So we need to differentiate again. So what I'm going to do is I'm going to differentiate from this one here. Okay, so again I'm going to differentiate. So d squared y over dx squared. Again, it's the quotient rule. So write down the bottom times the differential of the top. Now that's going to be negative 4x. Write down the subtraction minus the top one, which is negative 2x squared minus 2 times the differential of the bottom. Well, that's going to be 2x squared minus 1 to the power of 1 times 2x. And this is all over x squared minus 1 power of 2 to the power of 2. But again, for it to equal 0, we've got to have that top line. So let's just worry about the top line. So when d squared y over dx squared equals 0, it's going to be this top line here that is going to be equal to 0. Okay, so let's have a look. Let's try and cancel a few things. So we've got really two parts. We've got a negative 4x into x squared minus 1 squared, and we've got this negative 4x into x squared minus 1, and this negative 2x squared minus 2. If you guys can follow that, I've got 2 and 4 comes here. This here is there. Because these are all times, what I've done is I've just combined the 2 and the 2 to give me my 4. Okay, so hopefully you can follow all that. Now, I've actually got a common factor. Common factor of negative 4 and negative 4 and x squared minus 1 and x squared minus 1. So I'm going to take that out the front. Negative 4x, x squared minus 1, times that by x squared minus 1, the first part, minus this negative 2x squared minus 2. Again, this is quite tricky, but really what I've done now is I've tried to solve for some answers when d squared is equal to 0, because now I've got a place where it could be equal to 0. It could be equal to 0 here, it can be equal to 0 here, and it can be equal to 0 in here. Now this part in the bracket is going to be x squared minus 1 plus 2x squared plus 2, so that's going to be x squared plus 1, and again that can't equal 0, can it? Okay, so what we can do in here, we can have x squared minus 1 can equal 0, but it can't because it's a denominator up here, so that's not our answer. So we've only got the one answer, but you only one opportunity where x can be 0 that will give us a point of inflection where our second derivative is 0. Hopefully that makes sense. So, like, I understand this question is quite tricky, and the maths involved is quite heavy, especially the content. But you know, any sort of correct derivative gave you an achieve. So you know, any version of these ones, any of that was an achieve tick. A valid line of reasoning or explanation. So you know, this here, dy by dx, this can't happen, so it can't have a stationary point. There is your merit. And then it goes on to second derivative found and valid explanation, point of inflection. So remember, down here, can't, so these are the 3 points, there, undefined, so the one where x is 0, there is your excellence. You can't just have all of those, you needed to explain that the negative 1 and the 1 made it undefined, which is really valid. Okay. Okay, question 2 now. What have we got here? Find the equation of the gradient function. So we've got dy by dx, the equation of the gradient function. Okay, so that's going to be 3ex squared minus 1 times the derivative of that, which is 2x. I do not need to simplify, so there's my answer. Find the x coordinates for all the stationary points of that function. Remember from the previous question, stationary points is when the derivative is equal to 0. So let's go through it. I don't need to find the nature, so I just need to find. So I'm going to derive that. Now that is going to be the quotient rule again. So h dash x is going to be right down the bottom, x squared minus 4 times the derivative of the top. Now that's going to be from above, that's going to be 3e x squared minus 1 times 2x. Now if I write down, it's going to be minus right down the top, 3x squared minus 1 times the derivative of the bottom, which is 2x. And this is all over the bottom one, x squared minus 4 all squared. Now if I look at that again, I've got this and this are the same. So when I multiply it by that and that, I've actually got the same thing. So I've got a common factor. So what I'm going to do is I'm going to take that common factor out the front, which is 3 lots of 2x, which is 6x e x squared minus 1. And that's going to be, multiply that by this first part minus 1 all over x squared minus 4 to the power of 2. Now remember, stationary points h dash equals 0. So h dash equals 0. We're only worried about the top part. We're not worried about that part there. In fact, x cannot equal plus or minus 2 because it would make it undefined. So we're trying to solve 6x e to the x squared minus 1 and x squared minus 5 where that can equal 0. Now there's a few places because it's 6x, so I'll undo that one. There's 3 places it can be. You've got the 6x, so 6x can be 0, therefore x is 0. This part here could be 0, but actually e to the x squared minus 1 can never be 0, so I'll ignore that one. And then I've got this x squared minus 5 equals 0, which in actual fact solves to be x is equal to the plus or minus the square root of 5. So all the x coordinates, so my x coordinates are negative root 5, 0 and positive root 5. And for the last one here, this is a product rule. Remember from my formula sheet, sec x goes to sec x tan x, and tan x goes to sec squared x. So dy by dx therefore is product rule. Write down the first one, sec x times the derivative of the second one, so that's sec squared 3x times 3, because you've got to derive, using the composite rule, you've got to derive that middle part. Product rule, so it's addition, write down the second one, tan 3x times by the derivative of the first one, which is sec x minus 1 tan x minus 1 times by the derivative in the bracket, which is 1. I don't need to simplify. Okay, hopefully easy to understand where you get your achieve tick here. Again, a correct version gave you an achieve tick, understanding that these 3 points and getting all 3 was your merit, and then an equivalent for that, again hopefully pretty understandable for your achieved. Okay, so why is this increasing? So remember, if it's increasing, then the derivative of that is greater than 0. So let's find the derivative of this. So this is the product rule. So the derivative of g, so g dash x is write down the first times by the derivative of the second times by that composite function, add write down the second times by the derivative of the first. Now if I just tidy this up a little bit, that'll be 4x squared over x squared minus 4 plus 2 log x squared minus 4. Now I'm going to look at that, I'm going to originally I could try and solve for that. So I could try and solve that now to be greater than 0. But it's going to be quite tricky. So all I've got to try and do is, if that's going to be greater than 0, then all I've got to do is make sure that each of these components, so this component is greater than 0. There's another component here, because if all of these components are greater than 0, then will this not be greater than 0? So let's go through and try and prove that. Well, remember this is for when x is greater than 2, so when x is greater than 2, trying headers a little bit forward of my pen, apologies. 4 lots of 2 squared is always greater than 0, isn't it? When x is equal to 2, so whenever. So in other words, 4x squared is greater than 0. When x equals 2, x squared minus 4 will be equal to 0. So when it is greater than 2, this will be greater than 0. And again, when x equals 2, 2 times log of x squared minus 4, log of 0, does it even exist? No, it doesn't. So when x is, so hopefully you guys are following me on that, that should have been equal to 2. But now when x is greater than 2, that is going to be positive. 2 lots of a positive number, that is going to be greater than 0. So therefore, what this does is it actually ticks off that box, and that box, and therefore proving g dash x is greater than 0 for all x greater than 2. Probably not the easiest way about approaching this particular problem, but many of you probably like me tried to prove that first of all. But really it makes sense, doesn't it? If it's increasing, then each part is greater than 0, so why not? So understanding that correct derivative gives you an achieved. So using the product rule, being able to explain these ones and then therefore prove, there is your merit. Okay, so this is quite a cool one because it's a related rates of change question. Okay, so you are trying to find the rate at which the surface area is changing. Okay, so you're trying to find dSA over dt. Now to find that, you're going to have this dSA. Now we don't actually have the rate at which the surface area is changing. So how do we solve it? Okay, well think about the surface area of a circle formula, and what is the surface area of a sphere formula? Well, it's going to be equal to 4 pi r squared. Where do you find that? On your formula sheet. So the only way that surface area can change with respect to is the radius. But how's that going to help us? Because we've got a d volume over d time. So what we need to do is actually times that by a dr by dv. So it's a related rate of change where there's 3 involved. Remember. So what we need to do is, okay, so SA, so dSA over dr, that's going to be 8 pi r. We need to find the volume of a sphere. So the volume of a sphere is 4/3 pi r cubed. So dV by dr is 4 pi r squared. So remember, if we want dr by dv, we're just going to get 1 over 4 pi r squared using the reciprocal rule. Then dv by dt is decreasing at that. So let's put all those into my formula and see how I go. So dSA over dt, the rate at which the surface area is decreasing with respect to time. dSA over dr, the rate at which it's changing with respect to the radius, which is 8 pi r. Multiply by that by the reciprocal ratio, how fast the volume is changing with respect to the radius, which is 1 over 4 pi r squared. Times that by the rate at which the volume is changing with respect to time, which is negative 1.5. I'm going to write that because I'm going to find it easy later on. So let's try and simplify this. So I've got 4 times 2. 4 times 2 is going to cancel with that 8. Pi is going to cancel with pi. 1r here over this r here. It's just going to be negative 3 over the radius. So what is the radius? So the volume is 1,250 cubic centimeters. So from this volume formula, by solving 1,250 is 4/3 pi r cubed, we can actually solve for the radius. So let's solve for the radius. Now, so I carry on here. Sorry, I just paused it to do the calculations. And the calculation is getting away from me. So to do this, all I need to do is I need to go, well, r cubed is going to be 1250 times 3/4 divided by pi. So r is going to be the third root of 937.5 over pi. Now that will give you an answer of 6.68, and that's in centimeters. So the rate at which the surface area is changing with respect to time, because it's negative 3 over the radius, 6.68 centimeters, gives you an answer of negative 0.449 surface area, centimeters cubed, per minute. There's my answer. Excuse me. So remember, you'll find those on your formula sheet. So remember to look for them. Okay. Some progress made, including at least one derivative. So find either one of those and trying to form this equation. There is your achieved. You get that expression there. There is your merit in an understanding to find your radius from your volume, and then substituting it in got you your excellence. Yeah, quite a cool question, I reckon. Once you look at that answer schedule and hopefully look at the working, it makes potentially a bit of sense. I don't know. Okay, so question 3 here, dy by dx. Try to find, so dy by dx, 3 sine 4x. That's going to be 3 sine goes to cos x times the derivative of x, that's that, plus tan goes to sec squared, so it's going to be 2 sec squared 5x times the derivative of the inside. That's composite rule. Find the equation of the normal. Alright, so this is going to be a bit trickier. Find the equation of the normal. So let's go. dy by dx to start with. That's going to be 3 lots of 1 over x squared plus 2x times the derivative. It's going to be 2x plus 2. So that there, simplifying this one makes it easy later on, because I'm going to try and substitute that point in. So that's going to be 3 lots of 2x plus 2, so it's going to be 6x plus 6 over x squared plus 2x. That's the gradient of the tangent. Okay, so at x equals 1, dy by dx is going to be 6 plus 6, which is 12, x squared 1 plus 2, which is 3, which is 4. Therefore, the gradient of the normal is just negative 1/4. Therefore, the equation y minus y1 equals n into x minus x1. Y minus 3 equals negative 1/4 x minus 1. Now, I don't want that fraction there, so I'm going to times the whole thing by 4, which gives me 4y minus 12 equals negative x minus 1. Rearrange it. Oh, sorry, expand the brackets probably first, and rearrange it so it's in the same form. Equals 0. Again, hopefully pretty easy equivalent version of that. It didn't need to be perfect as that is, but yeah. So correct derivative, achieve tick. Correct equation, so understanding the normal is negative 1 over the gradient there, chucking it in there as your merit. Quite a big jump from there to there, but I know it's a derivative paper. Make sure you can derive, because you can derive what have you been able to achieve every single time so far. Okay, so here's your implicit differentiation one. Okay, so what you do is differentiate this side with respect to x and this side with respect to x as well. So let's just do that. So 3x squared differentiated with respect to x, 6x. Now this is the product rule, so you differentiate with respect to x first, and that will just become 4y cubed. Now differentiate it with respect to y cubed, so that's going to become 4 times 3, 12x y squared, multiply that by dy by dx. Same with this part, that's going to be differentiate with respect to x, so it's going to be 4xy, and then with respect to y, so that's 2x squared dy by dx. Other side, differentiate with respect to y, so it's just going to be 10y dy by dx plus 3. Now let's expand the bracket and collect all the dy by dx's on this side, on this side. So it's going to go 12xy squared dy by dx minus 2x squared dy by dx minus 10y dy by dx, and that is going to equal 3 minus 6x minus the 4y cubed, add the 4xy, because when I expand that, that's going to be a negative, take it on the other side, it's going to be positive, and that's what I've got. So take out the dy by dx part, and I'm left with 12xy squared minus 2x squared minus 10y, and that equals 3 minus 6x minus 4y cubed plus 4xy. So dy by dx is going to be 3 minus 6x minus 4y cubed plus 4xy all over 12xy squared minus 2x squared minus 10y. Now at x equals 0, y equals 1, dy by dx, so anytime it's got as x and we ignore it, so it's going to be 3 minus 6 zeros are 0, minus 4, because y cubed, that's 1, so minus 4 plus 0, bottom 12 times 0 is 0, 2 times 0 is 0, minus 10 lots of 1, which is negative 10, so that is negative 1 over negative 10, which is the same as 1/10. Okay, so for this one, you needed the correct x derivative, so you needed this one, this one, this one, this one. You needed those all correct for your achieve tick. For your merit tick, you needed at least one of these ones correct. And for an excellence, you needed the gradient correct. Okay, just make sure you know how to do these ones, because if you can, they're potentially easy marks. So value of x is -1, that's going to be 4. That's the solid dot. Where it's continuous but not differentiable, that is the sharp corners at -2, at 1, and at 3. The limit as x goes to -1, remember it's got to approach from both sides, so it's going to be 7. Where the function is increasing, well, that's going to be there. So x is going to be less than -1. Also between there and there, so it's between -1 and a half, and also between 1 and 3, but don't write it like that. Like that. And where is the gradient 0? That's at that turning point. X is -1/2. Okay, again, 3 of these correct solutions, so 1, 2, 3, 4, 5 options there for correct solutions. You needed 3 gave you an achieved, and all correct gave you your merit. Okay, this one here, make sure you can identify what you're trying to maximize. So here you're trying to maximize the volume, so you need a volume formula. Now the volume is going to be width 2x times length times x times height, or in other words 2x squared h. Now you can't differentiate with two variables like that very easily, so what we try and do is we use this piece of information where the y is 360 centimeters long. So in other words, if you look at this 360 centimeters comes from 1, 2, 3, 4 h's, 1, 2, 3, 4 x's, and 1, 2, 3, 4 lots of these 2x's. So in other words, 360 is 4h plus 8, 12, 12x's. Now, all got multiples, so they're all factors. 4, so in other words, we've got h is 90 minus 3x. I'll chuck that up here into my volume formula. So 2x squared times 90 minus 3x, well, that is 180x squared minus 6x cubed. So dv by dx, remember maximum, is going to be 360x minus 18x squared. Now my maximum implies that dv by dx equals 0. So where does 360x minus 18x squared equal 0? Solve that. Common factor of 18x. That goes into there 20 times, that goes into there x times. So I've got now two x values, x equals 0 and x equals 20. Now it's obvious that x equals 0 will give me a minimum, and therefore leaving the x equals 20 to be the maximum, but it says show. So how do we show that? As we differentiate that a second time. The second derivative is 360 minus 36x. So when x equals 0, d squared v over dx squared is going to be, well, positive, isn't it? Doesn't matter what it is, it just means it just is important whether it's positive or negative. Positive means it's concave up, which means it's got a minimum turning point. When x equals 20, d squared v over dx squared, 36 times 2 is 72, so it's negative 36, 720. Well, it's going to be negative. which is concave down, which means it's a maximum. So there I proved that 20 is a max. The question says find the height of the box. Well, the height of the box, when x equals 20, height is 90 minus 60, which is 30. Okay, there's my answer. If I want to be extra special, I'm not sure you have to. The volume of the box is 40 times 20 times 30, which is 24,000 centimeters cubed. That should be centimeters as well. Okay, and the last question of the paper, potentially one of the easier ones to do with a background in year 12. So, you know, trying to maximize the volume, so getting that part, correct equation. So this part here is your chi tick correct height found. So correct height in here, got you your merit. Correct answer, the logical reasoning. So where does that come in? It's probably going to come down to you proving the maximum and having decent working and following through there. But hopefully mine will satisfy that.